Ah, hold on. That's not supposed to be live. Whatever. Here we go. That's also like the wrong camera. There we go. Hotkeys. Hotkeys has something nice. So, yeah. Good evening, everyone, or good morning, or good midnight, whatever. So, yeah, I didn't plan on going live that quickly, but here, is my hair even good? Sort of. We're okay. Tea's hot. Perfect. So, what we're gonna do today is just another one of those Q&As. I feel like the 3D Senpai live stream Twitter thing that we did 1.5 months ago or something was pretty okay. People seem to like that, so we are gonna do that again and just like expand it to like a general Q&A sort of thing. So I'm gonna try to keep an eye on the chat, and I'll also have a look on Twitter on the hashtag 3D Senpai. Before we start with that, let me just grab one thing that I originally had planned for today. If you are following me on Twitter, which you should, you will know that I have this guy. But unfortunately, that was the original plan for today. Unfortunately, it's like the guys from iGo3D and the guys from Ultimaker. I want to have one of them in chat at least. I want to have one of them like around when I unbox this thing, just in case somebody wants to know something that I can't answer, or in case something's going wrong. I was originally gonna unbox this thing and get it going, but we're gonna have to do that next week, and so stay tuned to that. Just a short heads up teaser sort of thing. So, now that that's out of the way, literally. Right, let's get into it. Okay, so I am going to be looking this way more or less. I've got the monitor and the laptop over here, so that's my main attention span over here. So yeah, again, the Ultimaker, that was the plan. Unfortunately, it can make it happen next weekend. That's what I'm going to be doing. So yeah, again, tweet at Toms3DP on Twitter. There should also be like a lower third popping up every now and then that just gives you the social media info every now and then. So yeah, T-filter. These things are kind of cool. Silicone works. Right. Let's get the usual questions out of the way that come up every time. So it's already scrolled by. Someone's asking, hey, I've got my filament stored up on the wall in the open. Isn't that a problem? It is for some filaments. So PETs are sensitive to moisture. Nylons are extremely sensitive to moisture. PLA, ABS, just the standard types, don't really seem to be bothered by it at all. So those can be left out there pretty much indefinitely. I've also got a dehumidifier in here just in case, but that's pretty okay. And for those of you asking, hey, how do you even print with that? You can see I've got the Itopi with me today, and that is just straight up fed into the machine without taking the spool even off the rack. So that's that. I've also got another nylon printer. I've got the Markforged Mark II still with me. There are some problems I'm running into with that machine. I don't know if it's me mishandling the filament and getting that wet, but it shouldn't be an issue. It comes with a dry box. If you want to check out that stream, it should be relatively easy to find in my videos. So yeah, people are asking, PET is sensitive to moisture. Yes, PET is sensitive to moisture, more or less. E3D are actually pointing that out with their edge filament. There's one here. There's a few of them over there as well. I tend to dry their edge before printing. I also tend to dry PETs that have been exposed to wet or moist climates for an extended amount of time. The thing is, it's not as sensitive as nylon, which just starts bubbling and going milky if it's really moist. The edge, or PETs in general, will simply show a process known as hydrolysis, which has, I'm no chemist, I'm no polymer specialist, but the way I understand it is in the nozzle, in the hot zone, whatever water is in there, whatever moisture is in there will start boiling off. Of course, that's the whole idea behind it. And it will sort of break apart some of the polymer bonds. Don't quote me, please. And essentially have you ending up with a part that prints almost the same. Print quality is not going to be affected, but your part is going to be brittle instead of tough and chewy. So that's like the point with PET being moist or not. It's, again, it's not as sensitive as something like a nylon, which you can totally forget about printing if it's been out in the open for a few days. You are still going to be able to print with PET if you're not doing parts that are super mechanically demanding, that you need to put a certain amount of stress on it or load on it. Then you can print with PET that's out in the open, that you've washed with water. Perfectly fine, not an issue. It just takes a bit away from the ultimate strength of your parts. Yeah, show us the plumbus again. You guys can watch the entire video of that. The plumbus. Yeah, I can switch cameras. There's the close-up. For those of you not getting the reference, this is a Rick and Morty reference. The entire video is more or less, and they don't explain what it is. You're not supposed to know what it is. It's just it's sort of an inside joke, almost. I think it looks sort of cool. It's a nice it's a nice experiment to model that in sculptures. I really enjoyed that process, which is why I why I made it in the first place. So yeah, just to finish up on the PET topic, yes, PET is used for water bottles. PET is used for things that are in contact with water. However, it does absorb water. Even nylon parts that are out in the open do absorb water, and it's not detrimental to the part's performance once it's printed. It's just when you heat it to its processing temperature, it's not a melting point. Plastic don't melt per se. But when you heat it up to its processing or extrusion print temperature, that short time while it's at that high temperature, that's when it degrades if you're bringing moisture into the process there. So yeah, people are asking about the E3D Ultimaker 2 extrusion upgrade kit. So if you've seen that video, I think that was released mid last week or so. Or is it you guys and your nicknames? The thing is, the E3D extrusion upgrade kit is more or less positioned as an alternative to the original Ultimaker upgrade kit. If you already have an Ultimaker 2 Plus, if you already have that upgrade, it's probably not going to be as much value as if you're just upgrading the stock Ultimaker 2. You're getting a new extruder, you're getting a new hot end. That's pretty much it. The E3D hot end, of course, lets you experiment with different, actually I have one right here. Lets you experiment with different nozzles, nozzle sizes, nozzle types. This is an E3D V6.1 with a copper, which I believe is like a nickel or chrome plated copper block, and a regular copper nozzle. So that's for super high temp materials. Essentially, yeah, it allows the heater to transfer more energy into the plastic quicker. That's something you can do with the E3D V6 platform, but if you already have a reliable 2 Plus, then pretty much, is my mic peaking? Thanks for the hint. Then pretty much it's not as much value as if you're just upgrading the stock 2. Okay, the Mark II is not a good product, people are saying. that's an interesting thing. So it's a discussion that's coming up very often. It's, you know, whenever you're recommending a product that is not a $200 AliExpress i3 kit, people are saying, hey, what's the extra value in that? What am I getting for basically 3 times the price? It's still like the same printer, right? It's not just, it's more than it's on the surface. Yes, I've had one of those cheap Chinese. Was it Chinese? I think it was Chinese. The Malian M150, which is a clone of the Wanhao machines, of the Wanhao, whatever it's called, the i3 steel frame. And that one, it printed well. One of those benchies back there is the benchy from that machine. It printed well. It sort of worked okay, but it had many questionable design decisions, and 2, wasn't really set up for productive use. It was using safety settings that, you know, may have your printer burning your house down. That's the big point for me. It's also not really giving you any original development. If you're buying an M150 or a Wanhao duplicator or any of those other clone machines, you are not supporting any development happening. Yes, arguably the stuff that Prusa has put into the Mark II isn't his own original idea either, but he's the one who's making it work. Like the what's it called? The auto XY compensation, the auto bed leveling with the 9 integrated spots. Stuff like, what else? The quad extruder. Yes, that's not his own idea, but he's the one who's bringing it to market. He's the one who's making it work. And that sort of development effort, I think, is also something that's worth it. So yeah, FlashForge, it's sort of the same process. I will be getting one of the new PrinterBot Simples, the 2016 version, I think that's what it's called, with V2. I don't know what the I think it's just the 2016 PrinterBot Simple. There's no metal in the name. Okay, and that's a $1,000 printer. That's the introductory price, $1,000, and it's, yeah, print size wise, it's similar to like i3 kit machines, i3 style machines, but it's, you know, it's offering value beyond what you look for in a typical low-end 3D printer. It's giving you web connectivity, web slicing, which not a whole lot of other machines are doing, and particularly on the Markforged machine, they've got Eiger, which is their own web-based slicer, part processing thing, and I've really been enjoying that because it makes printing easier. It makes my life easier, and that's something that's definitely a bit that's definitely worth a bit of a premium. Right. Okay, PI, people asking. Yeah, so yeah, the Prusa is $739 for the kit build, which is, you know, if you take your time, it takes you a day to build, and that kit machine works just as well as the readily assembled one, which is 999 euros. US prices differ from that. I think it's $699 and $899 for the assembled one plus tax. Euro price is always including tax, so weird stuff. Am I going to try the multi-material kit for the Mark II? Yes, I will, but not the beta one that is shipping, sort of rolling out now. I will be trying the fully released once it's finished one. My experience with beta stuff is just it's always so much more work than you expect it to be, and I spent days just figuring out issues with other people's products essentially. So I'm sort of stepping away from doing beta testing. It's like, nah. Right, PEI, yes. Is PEI a bed surface worth checking out? So it's interesting. So what I've been seeing recently is a much wider availability of good print surfaces, be it PEI, be it BuildTech. BuildTech is maybe a bit too aggressive, maybe. be it coatings like the wolf bite stuff here, Magic Goo, that I've got a few pens, applicators, whatever they are. There's just so much of a wider range of products that give you adhesion to a print bed than there was like 2 years ago. And PEI is one of those solutions. PEI just works great for ABS PLA. It probably sticks a bit too well for my taste, but better safe than sorry. I've never had anything detached from a PEI bed yet, as long as the nozzle height was set properly. So yeah, PEI works great. It's awesome, but it's not the only great surface. You can make a clean aluminum bed like I have on the Service Reborn. Is that even? That's off frame. Great. You can make that work as well if you use the same, or if you use a proper, yeah. What are they called? Bed surface coatings, adhesion makers, whatever. Yeah, if you use something on there that gives you adhesion, and there are plenty of products out there that do. Would I say that the Raise N2 Plus or the Raise machines are a decent alternative to the Ultimaker? I don't know. I've not reviewed the Ultimaker 2 or 3, and I've also not reviewed the Raise machines. Joel Telling from the 3D Printing Nerd, I think, has done a review of the Raise N2. I think that's what the machine is officially called. He's done one of those. He's found a few flaws, but it looks like a decent machine. Again, I personally haven't tried either of those. We'll be testing ColorFab Engine. Yeah, so people have been asking about ColorFab filaments for Halloween. If you've been following my videos on YouTube, obviously, you might have noticed that last week has been a bit slower as far as stuff's falling over, as far as video releases went. I was getting a few comments like, dude, Halloween is so boring, stop doing that. And I was like, okay, maybe look at how I'm doing things. But the bigger problem was the Markforged machine. I had planned the release for the Markforged, the release of the review of the Markforged Mark II. And again, the machine has been giving me a bit of trouble, so that sort of delayed things. Yes, I've got reviews of pretty much all the relevant ColorFab materials. Okay, the stickers are all in the back. I've got reviews of all of those planned. There's plenty of ABS in here, there's plenty of PLA, plenty of PETs, plenty of flexible materials, so that's still going on, So, yeah. Does moisture affect print quality? Yes, it does. We talked about that a bit in the beginning of this stream. How do you dry out your filament? Yes, okay. I think that was asked twice or 3 times already. So, how do you dry out your filaments? That is mostly, again, a thing for PETs and nulls, because PLA really isn't affected by moisture that much unless you get like a super weird PLA blend. But the way I do it, the way I usually dry my nylons, is I just put them in the oven, set it to 60 to 70 degrees Celsius. Fahrenheit, obviously, 60, 70 isn't going to do anything. 60 to 70 degrees Celsius, whatever that is in Fahrenheit. And yeah, just leave them in there for half an hour to an hour to 1.5 hours. And after that, they're pretty much as good as new. If you set it too high, you will end up warping your spool and maybe even fuse your filament together, you know, basically rendering the entire spool useless. So don't do that. But like 60 to 70 degrees, just take your time, don't overheat it, and it should be good as new afterwards. Let me just, oh, look at that, there's the pop-up I mentioned. Let me look up what the 3D Senpai hashtag on YouTube is doing. Ah, yeah, okay, there's a good bit to dig into, perfect. Have I tried a 0.15 millimeter nozzle? No, I have not. I have 2 of those. I will definitely be trying that. I'm gonna make a stand for the plumbers. So people are asking about, is there a, hold on. People are asking about, yeah, okay, just to finish that topic with filament drying. So I think I'm gonna make a video on how to actually make a proper box for storing moisture sensitive filaments. Unfortunately I can't pick it up, it's right down there. The Markforged machine comes with an actual Pelican case that has essentially a Bowden tube connector feeding it into the printer, so the filament is never exposed to any, the open air until it's getting to the actual extruder, which obviously has open gears. But until then, or until that point, it's completely sealed. The Pelican case has a rubber seal in there, so it's totally watertight actually. What do I think about the Tico printer? You guys are always asking me about Kickstarter products. I feel like Maker's Muse is a better person to ask about Kickstarters, because I honestly don't care. Okay, I need to choose these words carefully. I'm not super excited about Kickstarter projects. And that is for pretty much one single reason, and that is you never know what you're gonna get. Whatever your product video is, whatever your sales pitch is that you're getting from Kickstarter, you never know if the product is going to end up better, if it's going to end up worse, if it's just going to notch, if it's just not going to ship at all, if it's going to be on time. By the way, Kickstarter projects are never on time, rarely. But it's like I try to stay far away from Kickstarter projects, especially after the what was it called, the Neptune, that one box. What was it, 30 I think, build volume. That one printer, that was just, it was such a horrible machine. And that's the status that these Kickstarter projects are launched in, with a machine that is barely usable, that is barely functional, and still they are they are selling like hotcakes. That's the thing that worries me. That's the thing that I personally don't understand, but well, the internet is weird. Can you print something? I can. I have plenty printers, so that's a yes. Will I print something? No. Yeah, okay. Mega Making is bringing up the Prometheus system. It's in one of those boxes down here. That's sort of a different thing, more or less. I don't want to sound biased here, but like when it's a company that has been in business for a few years, and the what are they called, the guys behind the Prometheus? Anyways, they've been making hot ends for a while. They know how to make a hot end. The concept they're selling isn't that complex. I've got one of those, one of the beta products here. It looks good. It looks like they know what they're doing. That's what I care about. And for that, that's the thing also. I talked to Eric Samud. I'm hoping I'm not confusing names here. And as usual, I was very clear. Okay, if we're doing like a sponsored thing, if you're doing like a product showcase or a discussion about dual extrusion, then it's not going to be a recommendation for your product, because again, it's a Kickstarter project. You might deliver something completely different to what I have here, so I can't really I can't make up an opinion from what you're delivering now, because it might not be the same thing you will be delivering to actual backers. So yeah. Right, people are asking about slicers. Okay, I should have disabled the Nightbot cyclic messages, but whatever. So, slicers. So we've got Slick 3R, we've got Cura, we've got Simplify 3D, we've got Craftware, we've got Kiss Slicer, if that thing is still around. And my opinion on slicers has always been use whichever one you're most comfortable with using. If that's Simplify 3D, if that type of working suits you, fine. If the simplicity of Cura is something you're looking for, totally perfect. If Slick 3R, just the sheer number of options in there is something you don't want to miss, totally fine. It's all about tuning the slicer to your printer. In my opinion, if you're buying a 3D printer kit, that should be the job of the manufacturer. So that's one of the reasons why print I bought, why the Prusa i3 Mark II, the original one, while Lulzbot are machines that I really like, because they are providing super complete slicer profiles that are plug and play. You load it up, you use it, it prints well. That is one of the most important things that I personally look for in a 3D printer, because if you're just getting a machine and then have to start tuning everything, that can be a few extra weeks of work to get it to a satisfying level of quality. And the i7 Pi, what i7 Pi are you talking about? The iTopy. Okay, sorry, but yeah, whichever slicer works for you. So I've been using Cura for support material, Cura 2.3.1, I think is the current one. I've been using that for support material prints, works. I've been using Slick 3R for support material prints, works. Print quality wise, they are very similar. Some slices do some things better than others, and in the end it just comes down to personal preference. By the way, how is lag today for today's live stream? It feels like chat is way behind. Can you guys type I hear you or something in chat on 3? 1, 2, 3, go. Just want to see how if this is working at all, because it feels like we're completely lagging today. I hear you. Okay, that's like 15 seconds. That's okay. Right. Okay. There's one. So Cyclone6 is saying A-net A8 is crap. Valid point. Okay, I hear you. So thanks, chat. I hear you guys too. So seems like 15 to 30 seconds. So I've been getting quite a few requests for like these super cheap machines. Chat is gone. Sweet. I've been getting quite a few requests for trying out some of the cheaper machines, like the A-net A8, like the TiVo machines, whether it's the Tarantula or Black Widow. And on the same token, I've been getting requests from the manufacturers going like, hey, we'd like to send you a printer to test, to try out. Would you be interested in that? And I was always like, I don't know, cheap printers. Sounds like too much effort to put in to get a working product, and then too much effort to, for that entire thing. But you guys have been asking for it, so I reached out to them, and I will be getting an A-net A8. Of course, we will be live building that. An A-net A8 and a TiVo Black Widow. So the one thing that's being brought up about those machines is usually, they're crap out of the box. I don't want to start out biased here. But my plan, as usual, as with any machine, as with the same same trial for any type of machine. It was the same for the Prusa. It was the same for. It's going to be the same for the Ultimaker. It's just I'm going to build the machine with the parts that are supplied, with the manuals that are supplied, and any upgrades, any tweaks, any changes that deviate just from the manufacturer's instructions, they're going to come later. The build and the review are going to be based on what the manufacturer supplies. So if those kits truly are crap, then yeah, I'm going to end up with a crap printer. If the machines are solely based on you're going to get a crap kit and then you upgrade, then you start upgrading, that's not going to be something I'm going to be looking at for the original review. So yeah, that's just that. So again, ANET A8 and a TiVo Black Widow are coming up, are going to be on this bench, and it might be like 2 or 3 weeks. We'll see. So let's actually get into the 3D Senpai part of today's stream. So, just take a quick peek at Twitter. Okay, so people are posting print issues that aren't issues, that look like perfect prints. Right, screen cap. Wow, that camera is dark. So Laser Lord's asking, hey, how do you get rid of curling? It's the main reason his or her prints fail. I have cooling, by the way. So as you can see down here, if I zoom in, all my other windows are going to get zoomed in as well. Ooh, works. As you can see down here, there's this rippling, this texture to the underside of these prints, and things are just, curling is an issue that is curable by a few different, through a few different ways. So first off, use the right layer height. Use a layer height that isn't too fine, because if that's just going to pump a lot of heat into your parts that isn't, sorry, okay, that does make sense, but fine layers tend to have more curling because you're passing over the same area with your hot end more often. Larger layers obviously are going to have steeper or more of an overhang per layer, so that's not going to be good for curling as well. So a medium layer height is usually what works best for curling. If you're using a 0.4 millimeter nozzle, that would be like 0.15, 0.2 millimeters. The other thing is temperature and cooling. Those two usually work hand in hand when it comes to overhangs and curling. If you're seeing too much curling, either increase your part cooling fan, if you have one, if you can crank that up even higher, or lower the print temperature. Just lower the temperature your part is printing at. The other thing you can also sort of look into is enforcing a minimum layer height, a minimum layer time, so that just if your parts are small, have a small cross section, they should just take a bit longer to print. There are two options for that usually in slices. One of them is just having the hot end move slower, and the other sort of is having the hot end move off to the side. In case you're seeing super strong curling that it can't cure with a minimum layer time, then you're gonna have to move the hot end away if it just keeps radiating heat into your parts. The other option is so either move the hot end away, increase minimum layer time, or put a sock on your block. Here we go. BA. So the E3D socks, they are meant. I haven't. Let's turn that off. I haven't actually tested them to their full extent yet, but essentially there are little covers that go on your heater block, and if I don't squish them on that side, essentially they just sit on there and their entire job is, well, twofold. First of all, it keeps the nozzle clean, so your filament debris isn't going to stick to the silicone cover, and it also insulates it, first of all, requiring less power to heat that entire thing and also radiating less into your printed part. So that's something that can help with curling too. These are super cheap, by the way. Prussia doesn't like them because he's saying they fall off, but he's pretty much the only one who's pointing that out. A few other people are saying, hey, they don't fit well, because if you look at them, like over here, you can sort of see this flap popping up, but these expand when they heat up. So once this thing heats up, it actually snaps onto it and really holds on to the block pretty darn well. Right, so I hope that covered the curling topic there. Yeah, so overhangs are sort of the same topic. Good overhang performance and low curling sort of go hand in hand. I'm hoping I'm pronouncing that right. Primož, okay, Primož, it's saying low layer heights work better for overhangs. Yes, they do. Do I have something to draw here? Yes, I do, I think. There's something I can draw on, and there should be a pen somewhere over here. Filament boxes. I have so many filament boxes right now. So essentially, yeah, improvisation. So essentially when you have your layers, and let's say this is your base layer, I shouldn't be using a reflective silver pen, but that's all I have. Oh, no, I have a pencil. Great. So how do layer heights affect overhangs? Essentially, if you have your one smushed down trace right there, and then you have your next trace sitting on top of the next of that one, and then your next one, and so on. That's essentially how much of a gap or of an overhang each layer has to bridge, has to overcome. Is that visible at all? Sort of. There we go. And if you essentially, if you lower your layer height, yes, you're going to have more smushed down. Super improvisational. You're going to have more smushed down traces, and each trace is going to overlap more. It's just going to be a smaller or shorter section over here that overhangs, and that's essentially the logic behind using lower layer heights for overhangs. Of course, once you go too low, these aren't going to have much structural rigidity, so what they're typically going to do is that they're just going to curl up, and that's also not really good, not that good for overhangs. So again, low-ish layer heights. Low-ish, not in focus, sorry. You get the idea. Low-ish layer heights work better for overhangs, yes they do, down to a certain limit. Also the other thing with low layer heights is bridges are gonna get worse. So that's just the general logic. Gareth Price using the socks up to 300 Celsius, I think. And perfectly okay. Yeah, so laser lower, of course, that's what I'm saying. If your layers get too thin, then curling is going to get worse at a certain point. What stream software am I using right now? That is OBS Studio. I feel like my cameras are way too dark today, especially that one. This one over here, maybe not so much, but that one is like, they're the same camera. They're the exact same camera. They are set up the exact same way, and still they look different. I do not understand this. Yeah, let's scroll through Twitter and see what else we got. Haha. That could be a good one. I hope that's not some sort of obscene video. Filament very brittle. Oops. Be there. With ABS being extremely brittle. Yes. No layer adhesion issues, 245-degree bed, 100C, 11-second video. So let's play that again. I like how it's suggesting German for me. Sweet. So extremely brittle 3D prints. That's sort of the same thing we talked about with moisture in the beginning of this video. So one, if you have filament that has absorbed moisture, some ABS do as well. Typically they don't absorb that much, but if you get cheap, bad ABS, yes, it might absorb some moisture as well. If they do that, you are going to end up with brittle prints. Also, if you print too hot, your prints will, as he's saying, no issues with layer adhesion at all. But he's getting brittle prints, and that could be an over temperature issue, because you are degrading your plastic in the hot end while it's being heated up and while it's at temperature. And the hotter you set your hot end and the longer you keep it in the hot end, the more your plastic is going to degrade, and that is exactly one of the things that that degradation would cause. So my suggestion right there, try printing faster, try printing with a lower temperature, and also try a different filament. Obviously, that's one of the things that you can never completely how to English. That's something that's always a possibility. The worst case of brittle filament I've ever had was I got a new spool of 1.75 millimeter PLA. It was some cheap off-brand stuff. Took it out of the box and it was just shards of plastic in the box. It was, you usually have your spool with nicely wound filament, and it broke into segments that long. So every 10 or 15 centimeters, the filament had just cracked. And I pulled out the spool and it was just the entire filament just falling off. So yeah. Do I watch Hardware Canucks? Rarely. But I do know they exist. Let's see. People are asking me on Twitter, what do I think of the Monoprice Maker Select V2? As usual, if it's a printer I haven't reviewed, if it's a printer I don't physically have here or have tested, I can't. It is impossible for me to have an opinion on it. Anything I say positive or negative about a machine that I don't have, that I don't own, or haven't tested, is guesswork, is speculation. So I will refrain from doing that. What is that? How can this happen? That's an interesting one. Catching up on chat. Okay. How can this happen? How can such a print happen? Morong Network Media is asking. So, yeah, essentially what we're seeing let's just go step by step, because, breaking down 3D printing issues, if you're looking at a part and try to trace back what is causing it, it's sort of the same. It's sort of the same process, which, independently whichever problem you're facing. So step one, what are we seeing? So what we are seeing here is this is really dark. I'm hoping you guys can see that. It looks to me like it's not under extrusion. It looks like it's actually over extrusion. But if you actually look at these might be gaps. These are it's hard to tell from the video. Okay, let's take into account two possibilities, two options. One, it's under extrusion, which essentially would be the extruder. Why can I not turn on this second camera? So under extrusion, this is the, I got a real nozzle here. So hot end travels at a constant pace, tries to lay down a layer, but it doesn't get any filament fed from the extruder. So all you're gonna get are like little drips, little dots that are like dip, 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 dip. And that is sort of something we are seeing here as well, if this is truly under extrusion. And that is simply a failure to feed enough plastic into the hot end, which can be caused by a few different things. One, your extruder is slipping. Two, your stepper driver is overheating and stopping and eventually stops driving the motor because it shuts itself down to protect itself. And the cause for the general thing, your extruder isn't feeding enough, your extruder is slipping, either extruder tension isn't right, the idler lever on the extruder isn't tight enough or is too tight, or your nozzle is blocked. That nozzle blocking thing is a plethora of potential issues. So if you have an all metal hot end, then it might be that you got a knockoff one, a cheap one, where the heat break isn't machined right and actually has the filament sticking to the bore on the inside, because you are touching semi-hot, semi-cool metal right in the focus is around here, right in the area where the transition zone is between the cool and the hot zone down there. That's something that cheap hot ends suffer from, and hot ends that aren't machined properly. Again, I keep pointing this out. I've never had that happen with an E3D V whatever, but just something a cheap hot end might have. Or if you're using a PTFE based hot end, that PTFE tube in there might be bent out of shape. So yeah, that's like the other option. So check the extrusion, check the hot end path, and try to unblock your nozzle. Typically, a nozzle block looks more extreme than this. A nozzle block is usually not as selective on the layers, so it might be something that's related to the stepper driver, or if it's a Teflon lined hot end, then maybe check that Teflon tube. Use curl-free filament here. Right. Clean the gear. Yep. Yeah, under extrusion can be somewhat compensated with slicer settings. However, if it's something like this where it's inconsistent, you can't really fix that with a slicer compensation at all. Okay. Mario is saying, hey, this part should be 20 millimeters tall. Recalibrate E-steps. Or the spool that's tangled. Mega Making, that's a good point. That could also lead to the extruder skipping. So back to this one. So Mario is saying the part should be 20 millimeters tall, and it's not. It's 19.68. Triptron. I will get into that in a second. So 20 millimeters, and he's getting 19.68. First of all, check that your calipers are actually zeroed properly. That would be the very first step. Let's assume they are. Now, the typical thing with Z height mismatches are expectations versus machine reality. So any 3D printer, every 3D printer has a discrete Z-axis resolution. So layer height, essentially. That's what it is. It's the same for SLA, SLS, SLM, FDM, jetting, whatever you want to call it. They all have discrete layer heights. Since this is an FDM part, or FFF, if you want to avoid the copyrights there, it's typically around 200 microns, so 0.2 millimeters, which manifests in an average error of 0.1. So, but let's see, we're at the extreme case, and it just didn't manage to cram in a layer, because whatever. That will put us at 19.88 millimeters, assuming it's a 0.2 millimeter layer height. That is just 1/10 of a millimeter off, and that's not too bad in my opinion. The other thing is squishing down the first layer. This first layer, as far as I can tell, let's see if we can get this thing a bit larger. There we go. So the first layer is pretty well squished down. However, it doesn't look over squished. If it was over squished, if the first layer is actually set, or if the nozzle is actually set too low and the printer ends up over squishing that first layer, that's also going to cause a part that isn't tall enough in the end. So that's the other option. Those two things, that's hard to pronounce. Those two things combined can already lead to a part that is, 0.32 millimeters too short. So yeah, those two things. Now, the other option, of course, is that the Z steps per millimeter isn't spot on. That your printer thinks it's moving up 20 millimeters total, but it just moves 19.68 or 19.7 millimeters up. That's relatively rare, since both threaded rods, even if you're using just the regular M8 threaded rods, those are pretty good in their tolerances. But also, like lead screws, proper lead screws are usually very close to their ideal value and not that far off. They're not off by 2%. So I'd say that's not going to be the problem. So again, first layer over squished, and just the natural inaccuracies of the process. Let's see what else we have. Michael Pauly is asking, is the E3D hardened steel nozzle okay to use with all filaments, or should I swap between steel to brass, I assume? Also PIO Captain. Yeah, so the hardened steel nozzle is pretty much okay to use with all filaments. That's a really simple answer. So you can use that with carbon fiber filaments. That's what it's made for, or also other particle filled filaments. Carbon fiber, the most abrasive one, obviously. You can use it with that. You can use it with regular PLA, with ABS, with PETs. It just works. Steel has a bit of a lower thermal conductivity than brass or copper or aluminum, but in reality, it doesn't matter that much. It doesn't make that much of a difference that it would render other materials unusable. So yeah, that's it. Yes, you can use a hardened steel nozzle with any material. They are more expensive to manufacture, which is why they're not default on the V6 or any other. They might be default on another hardened, but that's why they're not being more widely used. Also, PIO Captain. Hold on, I have to. What can? Is there another block? Yeah, there we go. Okay. I need to set my Nightbot administrative bot a bit more more aggressively. Whatever. PIO Captain, yes. Interesting topic. So PI as used on the. Can I pull this one forward? PI is used on the i3 Mark II or on some other 3D printers that are using coated beds. I think I have, yeah, that the other one is in my middle 90. So essentially a PEI sheet and a Kapton sheet. They are very similar chemically. They are, they are the same group of polymers, and they work very similarly. However, what I found, this is, so the Prusa uses Ultem. The Prusa uses, is it 3? It's DuPont. Ultem, PEI, that stuff sticks like crazy. Some of the Kaptons I've used, especially the Chinese ones that you could just get on these super thin rolls, those tend to not stick as well. And the problem with the Kapton film that you like buy on the 50mm wide rolls is that, holy crap, I have a thick one here, yeah. So like this type of Kapton, the problem I've always had with it is, yes, the materials stick well to the Kapton itself, but the Kapton doesn't stick well to whatever surface you put it on. So you end up with like a weird effect where your part will be stuck to the Kapton, but the Kapton just lifts up from your build plate. So yeah, that's the one big thing between Kapton and PEI. Kapton feels a bit crunchier when you pull the parts off, so again, it doesn't stick quite as hard, but in the end they are very similar. Goop. Just make that look a bit friendlier. They're very similar materials. The one thing I'd look for with both of them would be make sure your Kapton sheet has, or Kapton or PEI sheet has a decent thickness. So these are like these Kapton rolls. Big camera right there. So these are like a few microns thick. You can see it's pretty much, totally transparent. These are only a few microns thick. If you get the thicker ones, I think the Prusa is like 0 point, yeah. I think the Prusa ones, the Prusa's PEI sheet is like 250 micron or something, or 350. You can get them up to 800 microns or so, and that's going to be a super robust surface. So yeah, get one that is at least a few hundred microns thick, and you should be pretty much good to go. PET, Mega Making saying PET tape sticks a lot better. Yes, I also have some of the, PET tape has been around for a long while. So that's the PET tape you typically get, and I've been using that for a few years as well. It's a bit thicker than, there you go. It's a bit thicker, it's a bit more robust than the thin Kapton. But I found it actually doesn't stick as well as Kapton, and not as well as PEI either. So that's probably something that depends on the exact type of PET or PEI or Kapton you use. Okay, let's move on. So PEI Kapton, that's answered. Ah, yes. I guess we all know what that problem is. That tea is cold. So that is the typical, the absolutely an absolutely prime example of Z-wobble. As in, so Z-wobble is an interesting issue because it's not just a single phenomenon that's the same for everyone. So Can I pull this one out? Yeah, sort of. Let's use the iTopy to explain this. So USB cord dangling out and the filament is still attached, but that's okay. So let's look at the Z-wobble. So typically any machine is going to have a Z-axis. So this entire axis moves up and down, an X-axis and a Y-axis. The thing with X and Y is they are belt driven. Typically, this can vary from printer to printer. So they are belt driven. Belts, you can see they are sort of flexible. They don't have any stiffness to themselves. Same for the Y-axis. The belt down here, that one is very flexible, so that's either going to pull or push, and it's not going to press sideways. Now, if you look at your typical 3D printer build, is that visible at all? Can you see that? Oh. Let's try and get it on the other camera. So the point is, hoping that didn't crash anything. Heard some cracking noises. Yeah, ooh, what? That's not level. Whatever. So the thing is, any Z-axis, there we go, I'm hoping you guys can see that. Any Z-axis is not going to be perfectly stiff. So if your spindle that you're using, because Z-axis do typically use some sort of lead screw or spindle or the likes, if your spindle itself is not centered, if it's pushing the X end around, so let's say this one is wobbling around, then that is going to transfer to that entire X-axis in some way or another, even if it's just a minimal, deflection of your entire X-axis. Even that teeny tiny minimal thing can be. Can I zoom in closer? No. Yeah, even if it's just that minimal deflection, that is going to show up in your prints, because again, you are dealing with 400 micron nozzles. You are dealing with 200 micron layer height. So if you're getting like a 100 micron shift there, that's going to be 25% of your layer extrusion width, more or less, that is shifting around, and that is going to be visible. So yeah, Z-wobble. What can you do against Z-wobble? We actually just dealt with it on this machine right here. We were using M8 lead screws with couplers that weren't really that great. So flexible couplers, where's the focus at? Flexible couplers that allow the spindle to move around a bit. Obviously, these types aren't my favorites. You do have to pre-tension them, so essentially pull them apart a bit. Can you see that? Not really. Pull them apart a bit before assembling them, or they're just going to be flexible. These are assembled like that, so the only thing that's flexing is the motor itself and its shaft, because those are also on a flexible, but they're also sort of suspended in there. And yeah, use the right couplers, use Z-axis rods that are straight. And when it comes to anti-wobble brackets, essentially what I don't want to pull it up again. Essentially what the anti-wobble brackets tend to do is just put a second bearing on top. And I'm not a huge fan of those. The thing is, if you have a bent Z-axis lead screw, that wobble that you're seeing, it might just be wobbling like this, where you've got your nut on the X end right here, and it's sort of free to wobble because it's flexible on the bottom and it's free on the top. So if it just wobbles like that, you're going to see minimal Z-wobble actually being transferred to your X-axis. If you constrain it on the top, it's also constrained on the bottom. That's just, that's going to transfer into your X-axis more. It depends if those Z-wobble arresters work or not. Oftentimes they make things worse. Sometimes they make it better. It's just something you have to try out. Yeah, sometimes I do have to re-answer questions it's still better to answer them on video and have people watch them than typing them out in an email. By the way, if somebody's wondering why I'm not responding to emails like, help me please, my printer is not doing things. Yes, that is exactly the reason. I prefer to answer questions live to educate more people in a single batch than doing one-on-one support. You can of course book me for that, but it's not something I'm doing in my free time. So yeah. What kind of extruder was that? So yeah, that's the extruder from the original Prusa i3 Mark II. You can use that on any Prusa compatible, on any i3 compatible machine. The Itopi is one of those. The Itopi is using the standard belt and bearing and rod spacing. And so you can use any extruder you want, and we simply decided to put the Mark II extruder on those. Okay, Twitter. Will I try to, what? Will I try to build a 3D laser printer, SLS, SLA, DLP? So only, yeah, two of them are laser-based. The DLP one obviously isn't. DLP uses a DLP chip. So what the heck is going on there? Essentially resin printers like the Formlabs Form 2 or any of those printers in that vicinity. Yes, eventually I do sort of want to look into them. Yeah, eventually. Formlabs, if you're watching, get in touch. But yeah, like the SLS or, no, not SLA, sorry. SLA, essentially using a laser to cure resin in the spots you want and then pulling it up piece by piece, or DLP, pretty much the same thing, just not using a laser trace but a DLP projector to harden resin. Those are two technologies that allow you to get really high resolution and really consistent prints. The resin is extremely cheap still, yes. They can be extremely slow to print, but overall I think it's a good alternative technology to the FDM we're typically looking at here. Right. Dan Thomas thumbs down because YouTube keeps spamming me with these uninteresting live feeds. I don't know, man. If it's not something you're interested in, just don't watch. Come on. It's that simple. Yeah, so let's do one more. Let's talk a bit about the auto bed leveling. Infrared inductive probe mechanical switch. What firmware? Okay, Greg L is asking about auto bed leveling. It's technically it's not auto bed leveling. Technically it's a mix of like bed deformity compensation and like tramming, machine squaring. It's sort of all different concepts mixed into one. There are a few there are a few things that you have to keep in mind with each type of sensor. So I do have, I think, one of each of these. The optical one should be down here. So there is the inductive one. There's the rep. Do it. Is that it? Shit, if I'd find it actually. I thought I had one of the optical ones. It's in here somewhere probably. Is that it? No. There it is. There's the optical one and BL Touch or mechanical. I don't have one of those, but they're they're essentially just a small switch. So there we go. Inductive one, this is actually an M8, a smaller one than the typical 12mm ones. You can find these on AliExpress. Then we've got the optical one. This is the same one used in the E3D big box. I got that with the Rep Do It Wi-Fi. And then the mechanical ones obviously are just a switch that mechanically touches down and detects when it hits the bed. So the inductive ones essentially use an oscillating field in front of the sensor tip, and whenever you bring anything that's metal or conductive in general into that field, it changes that field, the sensor picks that up and triggers. The optical ones, this one at least, uses an emitter LED and 2 receiver LEDs and just looks how much the reflection changes as it moves down, and whenever that changes to something where it thinks it's close to the bed, then it triggers. Now the one problem I have with optical sensors, this one probably not as much as others. I also have one of those dual, what is it, brightness type sharp sensors. That one might be affected way more than this one. Is you always have fumes and other stuff going up from your hot end, from your extruded plastic. And if you've ever looked at your, not the heater block, obviously that has a lot of waste plastic on the bottom, but like fans and heat sinks and that sort of stuff, that will slowly get covered by gunk and goo and just brown, messy stuff, especially when you're printing ABS. And let's get that out of the way. And yeah, that's something I can see optical sensors having a problem with, because when it's not transparent, when it's a layer of optically opaque stuff over the sensor, then it's not going to be working anymore. This one maybe not so much because it uses that differential sensing. So that's one thing. And these tend to work with more materials than you think. Even glass that is sort of effective works with these. Is there a name on here? Escher Technologies. Yes, that's the one. Escher3D.com with these differential optical ones. Now the inductive ones, obviously they require a metallic surface. So if you use a glass bed or if you use a zebra plate, which I have somewhere, a zebra plate on top of your bed, or even the zebra skin, that's still thick enough, then it's not going to trigger. It doesn't have enough metal in there where it's going to set off a sensor with a relatively short sensing distance. You can get these with different distances, but the longer the distance, the less accurate they are going to end up. And the other type will be capacitive, that you can get in the industrial sensor format. And the capacitive ones, yes, they also work, and they work for every material, but just by design, they are less accurate than the inductive ones. So that's that. And mechanical ones, are all over the place. So I haven't really tried the BL Touch yet, but it looks like it's a good consistent platform. Others that have like a micro switch with a lever swiveling down can be super inaccurate, because that lever adds a lot of inaccuracy, and also the swiveling action where you just have a servo flipping it down, that can also cause a bunch of trouble. So I'm not a huge fan of those. Something like the Atom 3D's implementation, where it actually uses the nozzle to touch down, and then, I don't know if you can hear that click. Maybe not. And then triggers a switch like that. That's a bit better. And it should also does also take care of any offset adjustments that you might need to do. All right. Okay. FSR are the only leveling solution for you, James Snow. Okay. Yeah, FSR, so essentially force sensitive resistors. That's what they, I think. essentially the type of sensor that's used in kitchen scales, where the more pressure you put onto it, the lower the resistance is going to end up with, and the firmware can read that and sort of detect when something's hitting it. So essentially your hardened touches down onto the bed, that compresses that force sensitive resistor, and that's what triggers the probe mechanism. Can work, can totally work. I feel it's a bit too complex, but it can work. Auto mesh bed leveling is already, I mean, it might be, is it not in the, I thought auto mesh bed leveling was already in the productive Marlin release. It's definitely in the Prusa's fork of Marlin. That thing is open source as well, but it's definitely available somewhere, and it's being worked on in the official Marlin release, definitely. Right, I think that is a good point as any to call it a day for now. So we've done an hour 15 minutes. I think that answered quite a few questions. So if you want to get more one-on-one lovey-dovey time with me and get more of your questions answered, you just saw that that lower third for Patreon. I do monthly Q&As that are Patreon exclusive, that pretty much get all the questions answered that are asked. And at a certain tier, you can also join in on live Q&As that are one-on-one. So yeah, as always, thanks everyone for being here. You have been asking about more Filament videos. Those are going to come out next week. I also want to get out the Mark Forged. I keep looking below the table because that's where the machine's sitting right now. I also want to get out the Mark Forged review. That thing's been with me way too long. It's a great machine. It's just not working right now. We're working well right now. I think it might be just an issue with this particular machine. But anyways, yeah, more content. SLA, yes, SLA printer reviews. If a manufacturer wants to get in touch, sure, why not? It's confusing. Chat being 15 seconds behind, me trying to look into a camera onto a screen. Yeah. Anyways, what's planned for the next week? So next week's going to be hopefully the Mark Forged Mark II review. It's going to be more Filament episodes, more content about filament use, proper filament use. I've also ordered some stuff for PLA smoothing, so stay tuned for that. Next weekend, definitely, probably on Saturday, we're going to unbox the Ultimaker 3 with boxes still right there. And I'm really looking forward to that one. I don't think it's overpriced, just to get that thing out of the way. I think it's a technology, it's an innovator, and that's going to be worth something. So yeah, we're going to try that out next weekend. And until then, have a nice rest of the Sunday or Monday morning or wherever you guys are. But yeah, thanks for watching. See you in the next one. Cheers.